Okay, sorry about that. Slight glitch there. Should be good now. So, yeah. I left off yesterday, and I got to the hypervisor to the point where it runs and runs into the SPRR and garden execution stuff. So this, I want to... There's two ways I can deal with this. I can try to emulate it, or I can just turn it all on and use the actual hardware. The issue with turning it all on is that Mini isn't as it is right now. I can't turn it on in Mini because everything will break. I need to change the way. I need to make some changes to the way Mini maps memory to make it possible. It's not a huge deal, but I'm kind of curious to see if I can kind of BS this in the hypervisor relatively easily instead of like doing it for real. So the first thing I need to do is merge Sven's PR about discarded execution stuff. Which I already asked for some I already asked for some changes, but I think we're good with everything, so... I think this is the only change that... Yeah, we'll just ignore that. Yeah... Yep. Yeah, I'm just gonna merge all this. Because I want to use this register stuff anyways, so... I think we're good on this. Oh, there's a conflict. Damn it. Damn it. I can fix that for him. Can I do... Oh, wait, there is a web thing. Can you actually do this in GitHub now? I did not know this. Okay, it's the first time I tried doing this. GXF, memory... Oh, is that just the... Hmm? This is not a proper base merge. What happened here? GF... Huh? What? I think... what that's actually doing... Oh, it undid my fix of the order on that thing, and then added just string.h. That's fine. And then why did CPU regs... Oh, yeah, I did that in the most recent one, because I pushed the thing to use those things. So just that should be fine then. As long as it has string.h, then we don't need that. CF, yeah. There's nothing there, is there? Yeah. I think that's fine. I hope this works. I've never used the web GitHub like conflict resolution thing before. So okay. Oh, it did it as a merge. That's not how I want to do this. No, bad GitHub. Okay, let me do this manually. I knew I shouldn't trust that web interface thing. I have a ton of crap here, so let me stash that. And yeah. See, this is what I was hoping to see. This style of merge, not what GitHub does, which is very confusing. Yeah, so I think that's fine. Yeah. That is one nice thing. GitHub lets you push into other people's branches when they open a PR by default. So you can fix things. Yeah, I think that did it. Hopefully it didn't break anything. Actually, let's let it run the checks. And you know what? While I'm here, well, probably don't need that, but yeah. How many FPGA used in Apple M1? I don't think there's any FPGA used in the in M1 machines. I don't think they have any FPGAs in them. Let's see how badly this breaks. It didn't. Good. Cool. So, what I wanted to get especially was this. Let's do that. Hopefully nothing interesting. In proxy utils, no. In sysreg, there's this ARM and Apple regs, the JSON thing, and Apple regs has useful stuff. So I need to add some things in here that I've already been using in a hacky way. 3615, 14.6. I guess we're gonna just put this at the end. I think that's what they call it on the ARM thing. Actually, control register, yeah. 15, 14.6. Yes, there is a neural accelerator. I don't know if there's a DSP, but neither of those are FPGAs. We know some ACTLR stuff, so let me add those into system registers. Yeah. That's 4. And then that 12, actually, that's apparently a different thing, so that seems to have changed, which is interesting. And I should update that later. And you know what? HACR EL2 is going to be used soon, so. Then EL2, I guess, for that. Register 64. So that's not even mask guest count vtimer. What that actually means is basically means route the count vtimer through the GIC emulation, I believe. And a lot of other register bits here are interesting, so we'll find those out later. do it like this. You know what? Let's do HCR EL2 too, because it's a ton of stuff, but it's gonna be useful, so. And back to my block things. That was easy. Someone's asking about AMX. The problem with AMX is that it requires kernel support. And it's not hard to add support to the kernel for AMX. It's trickier to add support to the kernel for AMX in a way that is acceptable to upstream Linux. So basically, what I expect will probably happen is we will probably have AMX support as an experimental thing in an unofficial kernel tree. And if people find things to do with it that are worthwhile, that result in significant performance advantages, then that will be a good reason to push to get it upstreamed. Mm-hmm. Is it val, or did I just forget what I called that? Oh, it's value. I guess we don't really need to ever remove the CPUs. If I'm booting with CPUs 1, that's fine. So also don't need that one anymore. I should add these to ARM CPU, to Apple CPUX. But first, what's the issue with HACR? Hmm. Oh, did I forget? No. Hmm. Oh, does it not initialize? Ah. Yeah, well, value should default to 0. That makes more sense. Let's try running that. And while that's running, let me get my Apple registers. Where are my tools? Apple regs. Yeah, here. And make sure we have these. Yeah, so we do have that. Yeah, we have these hopefully. And let's add some of the others. Really should have all of them, to be honest. I wonder how badly... Can I just get this table? Yeah, I should just do all of these. It's the easiest way to format this. Probably just paste it and then do a JSON format on this. So basically what I want to do is... why is index 0 there? We shouldn't need that. What's that? What was that about? Oh, we did have that. For arrays, yeah. That's fine. So basically index 0 name, that there. Spaces there. Comma. Let's see if I can do a bit of a cheating formatting here. Basically, let's go to here. Don't need that. And then basically, if I just copy this, I'm gonna need a bunch of these first. No, block mode. There we go. Actually, I can just do a little cheat here. There we go. We don't know those, right? We're just gonna assume those were EL1. And then there's an EL0 here. 2. You look override. I don't know what that is. This maybe is EL1. And then take all the definitions. There we go. Get rid of those. That's not too bad. And now let's see if I can write some names for these. And you don't know what? This format might actually make more sense than the one above anyways, so I might just keep this. Yeah, hardware implementation, what? Dependent, that's what I thought, yeah. Running out of space already for these. Okay, let me add a few more spaces there. I can remove some from here, hopefully. Nah, actually, it's not a good idea. Hmm. That's wrong. No, it is right. 9, 9, 10, 10, 11, 11. This is 6. This is 8. And then we have 13s. 14, 16. And 21. Okay. PMCR power performance monitoring. I think that's where we are. What's ESR though? Performance monitor, something status register, but event selection register, that's what it was. And like, by the way, some of these names I'm just guessing, like from the short names that we do know. Some of these descriptions, I mean. I don't know what FED is. Yeah, the it's always called AP now. Yeah, like a pointer authentication, but APDA. Well, they call them pointer authentication anyway, but what is a PRR? I don't know what APRR is. I don't think we have an official like expansion of name. Sven had explanations for these. Are these over here? And those are SPRR, sorry. I don't know what this is. Was that about real AFP? No, they made that one up. And APS is the and U is Uncore. ESR event selection register 0. Getting close to the end there again. Or ECM. We don't have that, do we? What was ECM? Core mask. That's what it was. Run monitor PCM. PMI core Oh, yeah, right. So that's that's what it is. Yeah, makes sense. Two, three. And that's just the counters. I've been wanting to do this instead of have a machine-readable description of Apple registers for a while now. Makes it a lot easier to generate defines for other stuff. Cool. Okay. And now I kind of want to just put Sven's ones into the same format because it's so much more easy. It's so much more readable, but actually, I don't know if I want to do that right now. Also, why is that airing out? Oh, sorry, it's an array. And let me sort them. 361510, 361510. Yeah, those are going to be in here. Fifteen 12, 1580, 82, 81. Huh? Hold on. Am I in block mode? Yeah, I'm in block mode. I got really confused. Okay. Yeah, this should work. I should put that in at a tab line on not on the commas, but on the. Let's put it there. So it's 2 more spaces. Huh? Yeah. End? Oh, why did I end up with end? Huh? Well, so this is not ordered. Sorted properly. 1, 4, 15, 5. That's also not sorted properly. Is that correct? Oh yeah, because these aren't sorted, and I ended up deciding to do that. But I'm not even sure if I want to do that. I guess, yeah, I guess it's fine. I guess I can also fix the commas here. Oh, space code, yeah. Yeah, that works. Import EL1, enter EL1. These are mostly no fields, right? Yeah. Actually, I can probably just detab this whole thing. Yeah. Oh, I just realized it should have been all tabbed. Yeah. Should really be like this. In that case, this is off by 2 again. This is fine, yeah. That was fine. Okay, that works. And then just tap these out. I mean, yes, I can write an auto formatter for this, but if everyone does it in the right format from now on, we're fine. And it's honestly easier to read like this. Because then this is going to generate the Python stuff for me, so eventually. For now, at least I want to get the registers in. Okay, there we go. And I'll just sort them. Oh, well, the names. There's a space here. It should be there. Yeah. Okay, there we go. And they're all in 3.6. So let's see. Eight, 1, 2, yeah. Okay, cool. Sort like that. 15, 2, 3, 1, 6. 10. 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 9, 2, 10, 0, 14, 6, 12, 4. Yep. And the widths. Okay, cool. I think this is a reasonable format for this file. Yes, I'm going to try to emulate GXF. Or at least fake GXF. Not really emulated, but, you know. Like, enough that macOS will run. But I'm not sure how hard it's going to be. So it's going to be a bit of a test originally. I don't know what Fed is. A front-end decoder, maybe? Front-end decoder is a good guess, but I'm not going to risk it. Okay, so I left something running here, and it worked, so that's good. hv.py. And see if I broke something with a new thing. Cool. Yeah, we have those. Excellent. And now yeah. Was this a thing? Yeah. Should be sets. Oh, that's not gonna work though. Okay, so let's see how far it gets with that. All right. It actually crashed. Oh, I think this is where we were in the non-debug kernel. Interesting. Find entry, huh? Why is that crashing? I bet it's something with the device tree again. Yeah. Interesting. Backtrace, please. Uh-huh. Get sock base fizz, huh? 1 second, toilet. I might have just realized something. I might be calculating the physical base addresses in a way that isn't compatible with it accessing MMIO. Let's see. HV TBA fist base, vert base, minus fist base. Yeah, it goes on to like the DFs, which is a bit dodgy. Ooh, interesting. This is from yeah. Okay, that's just. Aha. It's getting RMIO. Device type, ranges, yeah. This should all work. Where is it faulting? Here. That address looks somewhat suspiciously low. Oh, that's the beginning of the map. Hmm. Yeah, that's not mapped, is it? That one is, but that isn't mapped. Why is it trying to read that? Oh, but that should be the device tree. Because the device tree is the first thing in RAM, isn't it? Hold on. No, there's stuff. Oh. That's the KASLR gap. Oh, is it rounding up? Ah, that's why sometimes it boots and sometimes it doesn't. Because it depends on the rounding. So it only maps from... I see. So in that case... To read the device tree, it needs to be at least that high. So there has to be a gap of whatever that is. $16 megabytes. To guarantee that we don't map. Yeah, okay, that shouldn't be a big deal then. Oh, sorry, delivery. Okay. Okay. Ooh, and now it died. Died where? Oh? It died building a subcon. Okay. No. That's weird. Oh no. Hmm? Okay, this is weird. I'm not sure what happened there, but anyway. Wait. Multiple prints? Oh, recursive? Oh shit. Yeah, okay, something's broken there, isn't there? Let's see. An exception taken from EL1T. Okay, we definitely don't want it locking anything for starters. Especially because, yeah, let's not do that. Let's just shadow that one. It definitely tried to do things. Yeah, it got pretty far this time, didn't it? Yeah. Let's set the TTBRs. It shadowed SPRs. Okay. And then the next exception was what? A move? MSR? No. Wait. Something weird just happened here. Exception taken from EL1T. Yeah. Why don't we have the code in here? Oh. FIQs. Yeah. It's turning on FIQs, and we're still catching those. That's why. It's the timer. That's normal. And then it's infinite looping on that. Yeah, because we were using that as a hack earlier for that, and then it goes to handle true prints. Yeah. Okay. So let's just not hook FIQs at this point. Because eventually that code is going to have to go into the C part and be a bit saner, but for now we don't need that, so do not do those. Oh, sorry. Should turn that into a... don't I have HCR EL2 already? I do. Let's suppose if I use it. Okay. And don't do those. Much better. Ah, yeah. Make it a little bit larger. What just happened here? I think I just broke everything somehow. Oh, duh. These should not have the prefix. Okay. Ooh. Hey, new sysreg. Interesting. Python exception list. Ooh, okay. Wait, what? Oh, zero rate. Ooh, cute. Yeah, I forgot you could actually do that. Yes. Indeed. For... Okay. What I'm going to do for that is in... Oh, this might be a little bit annoying. Because it's a struct, which is not a... Yeah. Basically. Basically that, but... Yeah, that should work. Let's do it like this. Save a bit of... Okay, let's try that again. It's a dummy read, but dummy reads are useful sometimes, so... Ooh. And now we have finally an Apple instruction. Oh, and we actually got an Apple trap. Nice. What is that? Nope, not that. That one. 12221. Oh, that's AMX, isn't it? That's enable AMX, isn't it? $127 here? No, that's correct. If it's not 31, then set it. If it's 31, the register doesn't exist, so... So, yes. This. 5. Yeah, that's what it is. Enable AMX. And that means that one of these MSRs previously enabled AMX for us, but it was ignored. Probably APCTL stuff. It's interesting. This is like a timer or something, but wonder why it keeps reading this and not, you know, the actual timer register. Is it the same as the timer register? I don't know. Well, whatever. I'll look at that later. But actually, that's a disable AMX instruction, not enable. And that looks like the disabled bit, all right. 3, 4, 15, 1, 4. Yeah. So but then it did pass. So that probably means that we have so that probably means that this is a separate EL1 and EL2 instruction register, sorry. Because what bit is it touching? A top bit. Interesting. It's just not going to work with EL1 call at this point. Basically, yeah. Aha, see? It's a different register in EL1. So the question is, what is the EL1-2 version of this? I need to access this register without using EL1 call. And I can probably... Can I set something distinctive? That should be distinctive enough. And now, find all registers. This is doing all of them right now, I think. Search for that. Let me see. Lots of exceptions. I should turn off... Wait, it's not set to quiet mode? I am setting it to silent. DWC makes it run over USB instead of over serial. But I thought I set this to... Did I break silent mode? Oh, it's EL0 is the one that... Yeah, okay. Let's just ignore that part for now. Or no? Oh, EL1 isn't doing the silent thing? No, it should be. Oh, I think it's because we clear this after some calls. Yeah, probably just that. Just silent. Or not. Whatever. Shouldn't take that long anyway. Yeah, there we go. That's it. 3, 4, 15, 4, 6. Yep. So if we do ML1 EL1 call and set it to 100 again, and then we read that, we get that. So now we know what know that's a pair. The question is, what is the name of that? AMX config probably. Let's just call it AMX config. So we're in data, Apple regs 341514. Let's call it CTL. And then 341546. Actually, there should be an there should be an EL2 version of this too, probably. Which we can find by doing the opposite thing. C0700, and then the script for that. Should find 2 registers, this one, and then another one. Yeah, there we go. So now we know that this one is the EL2 register, because this is going to fault. Exactly. So we have 3415 46 is EL12, and 47 is EL2. Yeah. So for those who don't know, this pattern is standard in ARM, where EL2 is supposed to use the EL2 register, and EL1 is supposed to use the EL1 register. But in VHE mode, to be able to run a regular operating system at EL2, this register redirects to this register. And then when the hypervisor running in that mode needs to actually access the real guest EL1 register, then it uses this one. The silly thing is that this CPU hard codes EL2 to be equal to EL1. So in EL2, so like this register always aliases this register in EL2, and this register always aliases this register, and in this register always aliases this register in EL1. So it's kind of silly, but well, it makes sense to be after the EL1 too, right? And actually, there's more stuff because we're definitely gonna have some of these SPRR things that are used for EL1 too, and that we don't know yet. So I'm gonna have to do this dance for a whole bunch of registers eventually. Like we have these EL1-2s here, right? Enter EL1-2, abort EL1-2, and there's probably more. Like GXF config EL1 probably has an EL1-2. Which I can find out by doing this. This is going to break Mini, isn't it? Oh, interesting. It just, it's not allowed. Interesting. Huh. What's that about? And these SPR permissions are probably also... Oh, SPR needs to be enabled first. And I bet these permission registers also have aliases. Yeah, so until that's enabled, that doesn't work. And this is going to break, isn't it? This is going to break Mini. Yep, as expected. It's kind of annoying. Which is probably a good reason to fix Mini so this actually works. But I can shut down the MMU and then it'll work. Yeah, I can do that. Everything is going to be dog slow now, but I can do it. And now the interesting thing is finding the EL2 version of this. But maybe I can guess it. 361510. If there's a pattern to how they named them, I might be able to guess it. Actually, I can do this at least. So do this, read it. Set to 1. Yeah, still 0. See, so clearly there's an EL1. There's an EL1-2 of this somewhere that we haven't documented. So I should find that. And can I restore? Oh, it was disable and restore. I forgot about that. Sven added those. But what I can do is turn it on in EL1, and that's still going to break because EL1 still uses the same page tables. But I can do .mmu. Oh, I just realized. How do I do the EL1 calls? I don't set them here. Oh, it should be the same. No, it shouldn't be the same. I set them here. Okay. You configure TTBR, yeah, and TCR, EL1. No, wait, EL1. But then what about the real EL1 too? Wait, do I just not enable the MMU and EL1? I probably just don't enable it. Yeah, hold on. How is that TCR? Yeah, I think I just don't enable it. Oh, let's find out. Yeah, it's just not enabled. Okay, well that's fine then. Then it's not. Then this shouldn't break. Yeah. Oh, but it doesn't work either because the host doesn't have it enabled, probably. Okay, so MMU disable. Yeah. Chain load that. Not the kernel. Need a new mini for this. Uh-huh. Do I need to pass that to P.MMU enable? Yeah, I need to pass it. And then in principle, I can just dump all the registers again before and after calling this, and that'll get me the EL2 register. And the EL1 is probably next to it. So if I do find all regs before. Ooh, oh right, with the MMU disabled, this is I need to turn off the frame buffer. Yeah, shell. Let's turn off that and oh god. Yeah, the flushing is annoying. Hold on. Okay, I'm gonna find all regs with the MMU enabled anyway because that's faster. And then there was the guarded execution things that Sven did, and that's the same thing I'm gonna do here is kill the frame buffer and the UART. And then set the disable the MMU. Make sure to remember that. And then turn that on. Then find all regs before. That's working. It's just noisy. Yeah, so we have more things enabled because of that. But I want to know about the one that changed. That's one, which is probably... Well, for starters, this should start printing registers properly, but... Where's my list? 3.6.15.10 is the config register, and then... Aha! I bet that's it. 3.6.15.14.2. Oh, and that looks very suspicious, doesn't it? Right next to other EL1-2 stuff. $14.2. I'll confirm, but I bet that's it. And then 14.3 appeared. With 7F, which is an alias for whatever this is. 361513. It's also something related to SPRR. Then 1.4 is interesting. That changed too. On 3. Then 14.3 is the alias register. So this would be EL1 in that case. Why does it say EL3? It's EL1. Three, 6, 15, 5, 15, 15, 5. Uh, 5. Wait, 14.2. Oh wait, no, 14.3 and 15.5 also showed up. Oh, that's interesting. Which one of these is it? That one's EL2 only, and this one's also EL2 only, huh? Is it EL2 and EL1 too then? Yeah, so we have 15.14.3 and 15.5.5. We'll find out in a second. Which one of these is EL1 too? But this looks like EL1 too, judging by the order. Let's find out. No, that's EL1 too, and then that would make this EL1, which is also going to be... Wait, no, both of these are going to be the same here, but the difference is the EL1 one, this one. Oh, interesting. That's... Oh, because it has to be enabled also. Yeah, okay. So I need to enable this in EL1 first. And then the enable config EL1 2. Oh, we don't have that yet. So that's another diff I need to take now, actually. But now of these two, config EL2, unknown one EL2. If I do this 1.3, it works. I set it to something else. It zeros, and then if I read the other two, SVR unknown one. Yep, that's EL1 too, as expected. And then if I diff after and after 2, after EL1, sorry. Yeah, that one changed. 6, 15, 15, 4. 3, 6, 15, 15, 4. Not surprising. That's SPRR config. EL1 2. And that's not an auxiliary control register. This is SPR config. It's EL1, EL2. Config. EL1 2. And then that kind of begs the question of GXF. And I bet these permissions also exist in EL1 2 modes. Let's not run any of this because it's annoying. So if I just do final regs, hopefully don't get any spam now. No, much faster too, so. So let me try finding the EL1 version of these permission registers. That's still 0. Let's just tell myself which one is EL1 and EL2 so I don't confuse myself. Actually, you know what? I'm going to make it easier to grep for and just call it like Fuba 2, yes. Fuba, this is 0 actually. Fuba 0, 2, yeah. And then SPR 0, call, that'll be from EL1. And then from EL1, from EL2, and from EL1 call 1, 1, and this will make a bit more sense. And then just grep for Fuba. There we go. SPR config EL1 2, did I forget to fill that in? You mean the contents, or? You mean the bits, or what? I mean, I'll add the bits later, but I don't. Right now, that's not important. Cool. So SPRR config. Perm EL0 is 361515. and 1.6. Yeah, those are the EL2 ones. Oh, interesting. And then it's like the real EL2 one is, interesting. Presumably, yeah, that fails and that works. Interesting. So that's the real EL2 one is that one then. Oh, this is yeah. So that's EL1 and that's EL2. Okay, so that's why they are consecutive, because they named them like that. And then the others. The 3.14, 15, 5.1. 3.4, 15. Oh, that's so weird. So EL1 2 is that one, the BA11, 3.5, 3.6, 15, 15, 7. Yeah, unsurprising. Also, did I just mess up the... Oh, something's weird here. The egg field. What was it? I forgot. Uh, 15, 15, 4 was it? Okay. Yeah. And then 15, 15, 7 is that. And then finally, this is the 0 for EL1. Oh, this is going to be so annoying. Oh, how do I even call these? This is going to be so annoying. 5.1 and 5.2. 14, 3, 4, 15. 5.1 and 5.2. Because these are the EL0 registers as set by. So it's basically that EL02 for this first one, actually. The first one is EL02 because it's EL0. No, EL2's. So EL12 means EL1 access from EL2. So this would be EL02 because that's EL0 access from EL2. And then the first one is EL0, the real EL. Do these even work from EL0? I don't think so. Oh, they do. Oh, they do. Lovely. Shit. Now, the problem is that these registers configure things for EL0, EL1, and EL2. But now the permissions of who can access these registers and for where they're mapped are... God damn it. This is what... This is the EL0 for the... It's basically EL0... EL20 is kind of what it is. Ugh. I hate this. So this means it's the EL0 register from the EL1 domain as seen from EL2. So this is the remap alias thing, and this is the opposite. This is the real EL2 register of the EL0. Oh, I hate this so much. If you have a better idea, I'll take it. But this is like... Was there something like this in ARM already? Was there like a... I don't think so. I don't think any of the official remaps do this. Like, stick EL0 into the mess. Oh, they do. What do they call them? H. They have an H in there, which is why. But that's because the real EL2 stuff doesn't have EL0 in this context, so it's fine because there's no duplication anyway. Like, there's no EL1 version of these registers, which is why they don't need to do this. Yeah. Yeah. Well, it's gonna be like this. Now I wonder if, like, the IPI register also has EL1 versions. Let's find out. No, that one is global. No. You see, it's not that. The yields. This is what you just said is correct for this one. The SPRPM EL02 is what you're saying. That's the EL2. That's the EL. That's the EL. So the register that EL1 sees for EL1 registers is accessed from EL2 as EL12. Therefore, the register that EL1 sees for EL0 registers from EL2 should be accessed as EL02. This one makes sense. The problem is this one. because this one is the no, really, give me the actual EL2 register. Like, this is useless because on the M1, VHE is always enabled. So this register on the M1 is only EL2 accessible and always aliases the same register as this from EL2. But if they ever release a CPU that supports turning off VHE, which would have been great, then this register will be the one that EL2 has to use to enforce its EL0. Wait, but that doesn't even make any sense because the EL0 regime in EL2 only exists in VHE mode. Why does this register exist? This register serves absolutely no purpose. EL0 only exists in the EL2 regime when VHE is enabled, which means this is always accessible as EL0. Why does this register exist? That's why this is so confusing. It's because this should not exist. Well, no, I want to document that it's here. Ah! I'm gonna leave it like that. I mean, it exists, so it should be on the list, but people should know that this is completely useless. Okay. Back to what I was doing. Okay, so I'm going to come back to this later because there's obviously going to be more registers here that I haven't figured out, but at least the config ones are kind of important, so it's good that I looked at those. I wonder where that unknown one is. So anyway, I was looking at the I was looking at totally forgot what I was doing. That crash earlier because of the undefined instruction, and this is going to be too spammy right now, isn't it? Yeah, AMX. So I needed to enable AMX, which means I should this one. I need to enable that in EL2 also. Because presumably no, this is I was redirecting that one. Now 3.4.15.1.4. 3.4.15.1.4 AMX control EL1. That needs to be redirected. To that one, just to double check that I'm doing the right thing. Yeah. And then 7 is EL1. Yeah, cool. So kill that, go back to the hypervisor. That should fix the AMX issue. Okay, that didn't work. Oh, but that might be... No, I'm not saying traps. Does it need to be enabled in both the hypervisor? So it won't work, but... Huh? What? Oh, yeah, okay, I shouldn't do that. Conflicts. I'm doing, for the shell, basically, I do a really ugly... actually, you know what? I should do it if callable. I'm still going to call it a sysreg, but I'm going to change those things to, in the shell, only callables. And I should do the same thing for the shell, mostly. Yeah. So it's possible that the hypervisor also needs to enable that. So let's try it in the shell. So if I call that, that doesn't work. If I turn AMX on, that still doesn't work. Interesting. Oh. Whoa, hold on. Oh, I bet I know what happened. I bet that needs an instruction synchronize. Yeah, that fails. That doesn't do anything. Hold on. That still fails, yeah. And then if I enable it, 8 at EL1, ISB, and then... yeah, okay. It needs an ISB. That's fine. And then... that fails at EL1. If I do it EL1, 2, and then ISB, that worked... Interesting. Did I get that wrong? This is not a thing, is it? Oh, is it just... Interesting. Is it just because floating point is disabled in general? Is that in P state, or where is that? No, it's a sysreg, isn't it? No, this instruction can be... Hold on, here's the funny thing. Oh, interesting. 22221. Oh, wait. No. Aha. Okay, so EL2 can enable... Yeah, so EL2 can enable the AMX, and then EL0 can... does that need an SB? No. That worked a second ago. Apparently EL2 can disable AMX if it's enabled, but not actually use it. Oh, okay. Oh, it's a toggle. You can only toggle it. Okay, that is weird. Huh, okay. So what about EL1? Okay, but that can't do anything. And what about... But the hypervisor can always do it. Okay, that's interesting. So if I do something that is not enabled, like op10, which is... to 100... Oh, sorry. Wrong number of bits. Yeah, okay, that works. Okay, so that's enabled. EL1 can't use it. Yeah. But EL0 can apparently enable it and then use it. But yeah, so there's clearly another enable for EL1, or it's a general floating point thing, which wouldn't be terribly surprising. Uh, no, that's the 30. That's the ER32. That's not what I want. Where is the what was the damn 64-bit one? I think it's in here. PSCR, that's what it was. FPSR. Yeah. No, but that is the same. CR. That's the same. There must be another bit somewhere to enable this for EL1, but that's going to be annoying. There's probably a like enable for virtualization bit in there somewhere. So let's see. So this works from EL2. And that fails. So what? I bet that's that top bit. I bet it's yeah. I bet if I do this. Yeah, I bet it's that bit. And now from EL1. Yep, there you go. That's it. The top bit is enable for this level. The next bit is enable for the next level. Can I just enable it only for? Can I enable it only for EL1? Yeah, I can. Yep. Those are worth documenting. So let's write them in here. Actually, these registers, the bits are sorted like that. I guess we can put it at the end then. That should do it. Or just call it E and EL1. So let's put this. I should write a generator for this. Basically, this thing. Don't need that. And then basically just Don't really need that. Cluster change the name. Like that. That should do it. Seems I broke this. Oh, that. I hate how JSON does not allow the trailing comma. And honestly, obviously don't need the empty ones. Cool. And I'm going to put some comments in there. Do it like that. So I only define these bits serve one time for registers that have multiple variants. So these are kind of classes. Sysreg. And then we need to forward that, and then we also need to enable it in our own. I don't know what that bottom bit is, though. Yeah, they're probably all 64 bits for sysregs anyway, I think. Okay. Where'd that come from? I have a problem here with some print exception things that don't do what I want them to do. So first of all, let me add that to print exception here. So it's a sync. No, that is correct. It is a guest exception sync. Wait. Huh? It's an unhandled sync, but um, no, it's if I queue. Hold on. Why did I get an FIQ exception? I thought I'm not catching those anymore. Oh no, the guest got an FIQ, and I am hooking FIQs too. That's why. Yeah. Duh. Okay. Yeah. So I don't want to do that. But it's not a sync. So why does it say sync? No, I'm confused now. Guest exception sync? Oh, no, it's a hypercall. That's why it's a yeah. Oh yeah. That's why. I want to return true, and then otherwise, let's say that might work. So I can just continue that. And now we have a data abort at EL1. Do I have any video yet? Oh, we have video. Haha. Which also means Yeah. We got serial. Okay. Cool. No, that return true, return false was deliberate. That was not a bug. That was because I was messing with that and I added a return true in front. And now it's a data abort, which is fine. That's probably a legitimate page fault, or not. FAR. Hold on. What was that? FAR EL2. No, FAR. Huh? What? What? I'm confused. Oh, did I lose when I made those not callable? Yeah. Where are those coming from, by the way? I was looking for everything in the shell that comes from. Oh, yeah, that's why I was doing it. Sysreg callable and IHSPO. Yes, only do Yeah, so for sysreg, I actually don't want that. For sysreg, attribute in dir sysreg, and then just brute force it. Hmm. Hmm. Yeah. Yeah. Da, da, da. So back to here, var EL1. Yeah, that looks like a legitimate page fault. Probably. Let's continue. And now we have a dia board. And yeah. Yeah, I think we're just page faulting on pages now. This is totally fine. This is paging in stuff. Okay, so obviously this is going to go on forever. So let's kill that. And in the hypervisor, if it's a sync, panic, debugger break, yeah, this returned true. Not unknown, sorry. Unknown always return false, but on sync exceptions, if it's a dia board or an IA board, print the var. Yeah, so obviously I need to check this a bit later. Let's put all this stuff here. Actually, is this coming from EL1 or EL1H? Yeah, okay, so it is... No, wait. EL1T, yeah. Not EL0, though. Okay, so let's move this up. Actually, let's just do if it's a board, then if it's not a debugger thing, then return true. Oh, I actually got a sync there. Oh, I got an exception in the... Ooh, what happened? Aha. Some register I actually can't read from EL2. That's interesting. 3615C3. What is that? Three six fifteen three zero. We don't have that anywhere, do we? What is that? Oh, it might be one of those SPR things where, like, if it's not enabled, it doesn't work. 361530. What region is that? That's suspiciously in the range of all this stuff. That. Oh, right. This is not Sven's version. Let's look at that, but I bet it's one of those SPR or GXF things. Which ones am I emulating right now? Just the SPRs and VMC lock. Yeah. So if I do disable TLR, sorry, SPR config. I don't have that. Enable that. And now it works. So it's an SPR thing. SPR what? I wonder now. Well, we have an UNC2, I guess. 361530. And I guess that's another round of what register is this? It does work. About 2 361530. And let's see about EL1. Yeah, the fucking frame buffer. Much better. Okay, so that's EL1 call, and then if I enable that EL1 2, that does work. And then if I set it to Fuba 1 and dump all regs. There we go. Those are the names. E1630, 341580 is EL1 2. 41580. Three, 4, 15, 80. And then 70 would be EL2. So, I don't know what this is, but we're going to just fake it. And also the first one, because why not? Though I get the feeling we're gonna explode really quickly after this. It's gonna start using guarded mode, right? I'm surprised it gets this far without trying to use guarded execution. Why am I printing there? What do I do? Why am I printing ACR? I don't need that. Okay, what just happened? 361510, that's another one. Oh, no. Apparently I typoed something. Oh, Unc 1. Duh. That was dumb. Frame buffers are just, it's literally just the memory that has whatever is on the screen right now. That's literally all it is. I mean, if you Google it, you're going to find it, but it's literally just like the image on the screen right now is the frame buffer. That's it. That's getting pretty far. And VRAM something. I don't know if this is an infinite loop or if it's actually doing something. This might be totally normal stuff. So what I also expected, of course, is that all this host-based emulation of MSRs is extremely slow. So obviously, at some point, I'm going to have to do this in C, not in Python. I don't know if it's making progress or not. No, the frame buffer is not what you print to the screen. The frame buffer is the screen. You print to the frame buffer and it shows up on the screen. Okay, I get the feeling this is not making forward progress. But I think this is thread switching at this point. Also gets to... this is FIQ probably. Yeah. I think that's what I want, actually. No, the numbers are the timer value. So that doesn't mean it's making progress. This is just some kind of timer register thing, which I should also document because I'm annoyed that I don't see what that is. I don't know if it's the physical timer or what that is. But let's find out, actually. Let's do a quick shell. Yeah, see, so... let's see about tval. Yeah, so that's the timeout value. What's the forget what the count yeah, there's that, right? And then there's this, which is the same thing, right? So it's some count VCT thing, alias. I don't know why it uses that instead of the standard one. The physical and the virtual timers use the same thing, so I don't know why they use their own thing. Seems kind of silly. 15, 3, 4, 15, 10, 6. And that is real from EL1 and not from EL0 yet. That needs to be enabled from EL0 anyway, but yeah. I don't think you can write to these. No. And then you do have the offsets, right? V off EL0. Which you can set to something. And there's... Yeah, so that does that, right? That changes the virtual counter offset from EL1. And that should be documented here. And does it change the Apple one? It does. And then to enable the physical timer in EL1, I needed to turn those things... where is the timers? Yeah, count HCTL. PCT, VCT, on PCT, VCT. Yeah, so like if I do like 10, I think that's right. What's TVT? Oh yeah, try. Okay, yeah. Yeah, so the physical now is available from that, and that has the offset, doesn't have the offset. And then the V off. There's a P off, right? Yeah. What? Did not save the... Is that not implemented? Ah. Yeah, must not be implemented. Or it needs the ECV. Hold on. Yeah, it doesn't support it. So yeah, it's just an alias for the V timer. I don't know why. It's not count val, it's count V, basically count VCT EL0, right? That's EL0 accessible. That's also EL0 accessible now because I made them so. Oh wait, EL's... Oh yeah, because I'm in, yeah, from EL2, yeah, this is the EL2 version of EL0, so it works. I don't know what would happen from the EL1 version of EL0 because I haven't done that. I would have to change the hypervisor control stuff, which should be rather confusing. Actually, no, it wouldn't. I need Pt equals 0. And then if I do that, EL1 call shouldn't change. It's going to, yeah, actually, if I do EL0 call. It sets it to 1, actually. Yeah, I think EL0 call will reset that for me, which is not what I want to do, but yeah. Is this a thing? No. This is only if something exists. Yeah, HCV. Yeah, we don't have that. Yeah, I don't know. It's an alias of the physical timer, so it's basically count. Let's count VCT EL0. I don't know why this is a thing. And the encoding is 3, 4, 15, 10, 6. I don't know. Something. Maybe it's a synchronization thing, actually. That wouldn't surprise me if it behaves the same, but it synchronizes with other instructions or between cores in a different way. Because this is a thing, right? The counter timer self-synchronized virtual count register. And yeah, it's like the don't speculate version. It might just be a pre-standard version of this one. That would be very Apple. So that could be experimented with by trying to like speculate and see if it returns different results in that case. But not now. Okay, so we got that. And where did I leave off? Yeah, it was just reading that all the time. But I don't know what... I mean, at this point, it's obviously just thread switching, right? But it's possible that it's not making any forward progress. Just because it's too slow. That's entirely possible. I'm just gonna print page faults to see how much we're hitting on that. And then let's just run it. And I might just leave it running for a while I go get dinner and stuff. I'm not seeing page faults. I'm seeing a lot of MSRs. And interrupts, right? Yeah, FIQs. So it's getting timer interrupts. The thing I kind of fear is that if this is also slow, that like the timer interrupt happens very soon. So like the interrupts are causing it to not make forward progress. That could happen. So the other thing is I can. By the way, I kind of wonder where it is. It's some NVRAM thing. Yeah, it's the same pattern. But the thing is, I don't know if it's, for example, like in a trying to make forward progress, but not making any forward progress because like the timer is firing to as soon as like it tries to return to user space with a timer, and by the time it actually returns to user space, the timer has already fired. You know, that kind of thing. Yeah, I can grab some PC samples. I can print where we are in when the timer fires actually, which is the interesting one. We can trap the timer registers and then scale things. Yeah. Oh, it's doing stuff. See, PMAP export. The timer is firing in different places every time. And it went ADDR there, not sim actually. But there's a lot of like mock absolute time and yeah. So see, there's dictionary init with dictionary EPKS, mock absolute time. There's a lot of like timer related stuff, right? So I feel like it's making forward progress, but just so slow because of all the timer interrupts. And the problem is that like faking the timer is a little bit tricky. Though now I kind of wonder if I can do a thing. Nah, too annoying. And I know the interrupts go through the guest directly. The thing is, I can just turn off virtualization for a lot of these MSRs. The thing that I need to do is make sure that the ones I trap are actually like that. And so in that case, I have a list of these here already. The ones that because right now I like unconditionally trap everything, but I can trap more finer grained MSRs. So what I can do is here in the ARM Apple rings in the hypervisor, I'm looking for, first of all, find me these, which are the ones I care about. Stick that temporarily there. And then the mappings for those are actually, you know what? I already have, I can just rerun this. This nice script. Hacker trap bits, but instead of doing it like that, I can just print the proper names that we just figured out. Where's h3.py? Proxy utils. Yeah. This rag drive is what it was. And you know what? Let's just call it is this the right encoding? It should be, yeah. Can I just do this properly? Yield 3, and then I can sort it, add it. That didn't work. Why? Oh. There we go. Except it's not showing any names. Why? Oh, there we go. Oh, cool. This is exactly the one I don't want it to touch. Excellent. So in that case, instead of trapping that, what I do is hycr dot trap let's make some names for these. Some of these are sort of different from the others. I normally want to put the top bits to the top, but yeah, let's do these the other way around. And actually, I want to put these in the definition and then actually generate it. So let's put it in here. Oh yeah, that's right. This is. I guess I can make that alias thing. So for HACR, like for the standard registers that aren't actually standardized, this that, then I can just deal with it. 3, 4. It's 3, 4, 1. Yeah, because it's not implementation defined. I'm just gonna put these at the end to sort of break the pattern because it's useful to have them separate. Year 2, right? Yeah. Mm-hmm. Mm-hmm. And we said bit 20. Sorry, I know you can't read that, but let's just go like that. And yeah, let's start some of these bits. Okay, so bit 0 is trap. APCTL, AFPCR, APSTS. So this is basically Apple state. There's probably more Well, actually, I don't know if it would trap the. Didn't we have an? Was it APCTL? Hold on, it was HCTLR, so it was, yeah. Which I kind of want to check some of these registers too, actually. I'm gonna be surprised if some of these also get trapped, but yeah, these are basically trap Apple state extensions, I guess. Then we have whatever that is, 361527. I don't know what that is. I guess I can put it in as an unknown. Fill that in some other day. These all look like probably AMX. Maybe more things, but let's call it AMX for now. We'll see what those are about later. That's 10. Oh, look, SPR is 11. Definitely want that. And 13 is GXF. $14 looks like CTRR. Uh, 16 is IPI. That's interesting. Don't know what this is. Trap. I don't really want to put a comma in here, but don't really have any. 902.19. Zero 12. 5. Yeah. 25. And 48 is um 49 is hid. Oh, E hit, actually. Oh, wait, no, but hit because it's going to be... This is the E core, so I only get the E hits here. But... Oh, no, it is both, actually. Interesting. Okay, so 49 is E hid. Then 50 is hid. That's interesting. And then it breaks them up like that. 51, I don't know what that is. $52 is trap ACC, I guess. And then 57 PMC, PM, and 58 is UPM. 58, yeah. 59, I have no idea what that is. That looks interesting. There's a lot of stuff too there. And C7, yeah, whatever that is. There's a lot of stuff in there. Yeah, no idea what that is. Okay. And so now what I want to enable is trap. To be honest, I also want to trap the hits and the hits, and then the SPRR, GXF. Let's put them in the same order. CTRR. All that stuff is useful. And trap EHID and HID and ACC. Those are probably the good ones we want to take care of. And also, the nice thing is that like these traps will group registers, right? So now we know that all those are related, and it'll make it easier to figure out what's what. So, and now generate that. Exactly this. And now I don't have it. So I might have a fault or something now if it ends up trying to use a register that I haven't trapped and that is disabled. We'll find out. We'll see what happens. Because then if this works and I don't get weird guest traps, then I can start thinking about untrapping guest FIQs, which will... Ooh, interesting. Yeah, I know about that one, but... Didn't quite work, did it? That didn't even get me the V-bars. Maybe that's why. Maybe I can leave this on for a while and then eventually turn it off. Wait, why didn't I get the new V? Yeah, because I was shadow SPR. Wait, no, but it is SPR is the first thing it does. Why didn't that work? Why didn't it work before? Why didn't that work? Am I setting that somewhere else? No. Oh, it's not that. It's nowhere. Okay, so just to see what happens if I just set this to trap a lot of things. No. I guess it's crashing early because it's trying to do something that it can't do early. So there's the AIDR EL1 thing. When does that happen originally? It should be doing SPR stuff already, and it isn't, so something is wrong with the traps. Because that imp def thing is like... I thought it was way later. Are we not getting that? Something's weird. So by the time we get here, we can probably afford to start. Okay, so let's see what happens if in the first skip. in the first skip of that. Sick override. Mm-hmm. Oh. Interesting. Oh, we're getting impdef exceptions here on. Oh, it's not AIDRE1. Oh, okay. Oh, hold on. That's why. It's a different exception type. That's why. Sorry. That's why I'm confused. That I get that exception on the yeah. I get that exception on the Apple ones. That's why. The thing is when I get that exception, that's why. Okay. So in that case, that's why, because then that auxiliary register also counts as one of the trappables, which is why I was getting that earlier. I see. So one of those bits is AIDR EL1. Well, let's figure that out real quick. Might as well. And in fact, I can just add it here. Oh, and I bet AFSR has something interesting for me, like the MSR bits here. I need to check those registers if they exist. Oh, yes, they do. And I bet these also have the EL1 2 equivalents, and we're going to have to find them. Okay, let's do a find. Yep. I thought I trapped that. Oh, yeah, it does that. Just do that. Huh? Did I delete something by accident there? Yes. But, yeah. But I really want to hide that, honey. Utils, MSR, RMS, proxy utils. Oh, duh. It's because I... yeah. What is this EL0 thing anyway? That's useless. Yeah. That didn't work though. Oh, yeah. There we go. Oh, AIDR is in 4. Okay. Oh, I bet this is just the EL1 2 version then, or something like that. Let's read only as expected. And then what about the funny one? I bet it's something to override that register from the hypervisor. Or not, but it's interesting. That does exist there. Is it writable? No. So it's probably some other ID register. 361527. It's probably a secondary AIDR, I bet. Or maybe like a feature ID or something. Yeah. It might be like a floating point implementation information or something, but yeah, basically some kind of static thing. So that's 27, and then here we can call that trap AIDR. Which is what I was seeing earlier. And anything else interesting here? Interesting that like the HCTLR and stuff are not trappable. Unless I missed something here. Oh, but AMAIR is in there. Interesting. I wonder what this is. Yeah, and there's ACTLR, as expected, is in bit 0, so I totally expected that one. It's really aesthetics. It's like it's kind of state trap. It's like trap state. Let's call it trap CPU. Like CPU extensions or something like that. I'm gonna update that. And that goes in sysreg. And now what I need to do is figure out how those traps work. So if I do EL1 call of that and then set everything on there. That didn't work, did it? Yeah. And now the interesting thing is there anything in AFSR 0? Or in 1? Aha! I think I know what this is. I think I know what this is. This is the encoding of that MRS. I was hoping this existed. Cool. Oh yeah, it's a hypercall because of that, but that's okay. That's what I wanted. Unknown. Oh wait, no, but it traps to EL1. No, hold on. No, that's not right. Hold on. Why did that get reset? ImpDef, yeah. So syndrome 20 probably means... Are they all the same? That's a good question, actually. If it's hard, you want to call. So if I do like... that's 0. Oh, it's a different one. Oh, hit 0. Oh, sorry, that might just not exist. Yeah. They're all 20. But I bet that's what I said is the encoding. Not ARDR, sorry. FSR, yeah, AFSR EL2. Yeah. This thing here. Yep. 37100. Yep. Exactly what I expected. Up 1. Yep. TRN, CRM. Yep, exactly. So I need this. FSR1 EL2 is what's going to do the decoding for me. So in that case, if it's MSR or and that is 20. If it's an MSR, then we code it like that. Else, where's the self-res? FSR1. Cool. And now in the hypervisor, I do the same thing. Actually, now we just do it here. And then in impdef, that should do it. And it's not even impdef exception, it's just... Oh, we're gonna get the dumps anyway, so... And now, actually, CP, we don't need this. Okay. Exception 0, but no target. Okay, something broke. HGC... Why? I need that. Yeah, I still want to do that. Instead of return false. Only do it in that case, and then actually show me what's going on. And then basically what I need to do is make sure that that never returns. Oh, do you have vector? Yeah. Oh, we should have a vector. Address 17 offset. Oh yeah, I need some fake target anyway. One second, door. Okay, let's see what happened. Unknown. Okay. So it died on S3-1516 as an unknown. Oh, that's interesting. So I can't use that in EL0. What is that? V6-1516. Ah, SPRR, because it's disabled. That's why. So probably there's another bit for those. And I bet it's the one. Okay, so I'm going to do one more guess here that in sysreg that bit 12 there is what I want. And if it doesn't work, whether it works or doesn't work, I'm going to call it a day because I have stuff to do. I need to get some dinner because I am starving. But let's do a... Oh, wait, no, I did set all the bits in HACR. And it didn't trap. Oh, that's weird. So it did run things. It shadowed enabling SPRR. Maybe there's no way to do that. Maybe there's no way to trap. Maybe there's no way, or maybe I messed it up by setting all the bits. Let's try it again. So unfortunately, if I can't trap that, then I can't virtualize this without hooking the guest exception vectors, which I really don't want to do. So if that's the case, then the right approach for this is to... Yeah, that's not good. Okay, I'll have to think about this and see if I can find some other way of trapping this, or if there's some other bit somewhere. But if there isn't, or if it cannot be fixed in some other way, then yeah, I'll have to think about that. But I think that's enough for today. That was a lot of figuring out registers, so yeah. See you.